Good afternoon, ladies and gentlemen. My name is John Dyer, and it's my pleasure to introduce a section on network technologies. We're covering 3 topics this afternoon. The first speaker is Masashi Eto, I hope I say that correctly, who's working at NAIST in Japan. His particular interests are in auto-configuration of the Internet, which is wonderful. Welcome. And also secure web services. But this afternoon he will talk to us about the Internet Routing Registry, in particular the problems of propagation and inconsistencies of the database. So if you'd like to go ahead. Thanks.
Okay.
Thank you.
Yeah. Sorry. Good morning, everyone. Good afternoon, everyone. I'm Masashi Eto, Graduate School of Information and Science, Nara Institute of Science and Technology, Japan. Now I'd like to talk about my research about improvement of consistency among S policies on IRR database. BGP is crucial to the overall reliability of the Internet, but faults in BGP have been known to disrupt large regions of the Internet. For example, in April 1997, S7007 accidentally announced routes to most of the Internet and disrupted the connectivity for over 2 hours. In April 2001, S3561 propagated more than 5,000 improper route announcements from one of its downstream customers, again caused the global connectivity problems. To alleviate this problem, Internet Routing Registry, IRR, is expected as a tool that reduces overhead of operation on BGP network. IRR holds policies written in Routing Policy Specification Language, RPSL, that are registered by operators of AS. These policies consist of information such as AS numbers, maintenance of AS, and routing policies, and so on. Operators can generate router configuration from policy written in RPSL with a tool called rtconfig. I'm sorry. However, operators generally view IRR as an obscure and difficult rather than an unusual tool for network operations. This understanding prevents the widespread use of IRR. One of the reasons is that there are many inconsistencies on IRR database. That inconsistency between peering contract and its RPSL description given to IRR. As a result, when we generate the router configuration from IRR database, connectivity will be lost. To find out consistency systematically, we need to check inconsistency in routing information imported from other peers and inconsistency in routing information exported to its own peers. This is an example of inconsistency in routing information import. In this figure, S1 and 2 are under contract that S2 provides transit to the track from S1 to 5, 4, and 3. According to this contract, operator of S1 registers this policy, which is configured to import the root of S2, 3, 4, and 5 from S2. By the way, this is the policy whereby operator of S2. In this policy, root of S5 is missing by accident. If the operators commit these configurations to their routers as they are, router of S1 couldn't receive the root of S5, so that S1 couldn't establish connectivity with S5. This is an example of inconsistency in routing information export. In this figure, S1 and 2 registered these policies. In this case, S2, the transit provider, registered the proper policy according to the contract. However, in the policy of S1, sentence to import the root of S1 is missing by accident. As a result, S1 could establish the connectivity with S5. In this research, we aim to establish a mechanism to conduct an examination on the global scale with appropriate efficiency. We define the following approach. At first, we propose and implement a system to examine the consistency of S policies in the whole IRR databases in the world. Second, we propose and implement a system called policy check server to prevent increasing such inconsistency. And we analyze the results of the examination and perform qualitative evaluation of the implementation. To examine how many inconsistencies are on IRR databases, and to prevent increasing these inconsistencies, we propose policy check server, which consists of 3 main components. To examine the consistency between assets, we need all policies of whole IRR databases in the world. Therefore, we construct a common database called Unified IRR Database, which includes all policies by DB generator. Database checker inspects how many inconsistencies exist on Unified IRR Database. Policy checker examines whether the policy which the operator of S is about to register is consistent with the policies of peering ASs. Then we make clear the necessity of inspecting the consistency of the policies. We implement these components on Wine Linux version 2.5. And most components are written in Java language. We applied Apache and Tomcat to construct web-based interfaces and Postgres for Unified IRR Database. Database checker examines how many inconsistencies exist on IRR database. Therefore, we make clear the necessity of policy check server, which assures a policy is consistent with other policies. Database checker outputs the collected inconsistencies to the log file. The algorithm consists of 3 phases. At first, database checker specifies the peering S by import or export sentences and hold the peer S as an S object, which has each value in S's policy. If information about the peering S doesn't exist on IR database, database checker flags the information as an inconsistency. Second, database checker compares import sentences of input S and export sentences of the peering S. If the peering S doesn't have export sentences which specifies input S as a peer, database checker collects the information as an inconsistency. Otherwise, database checker checks whether the peering AS exports the root prefix, which the AS intends to import from. If it doesn't, database checker collects the information as an inconsistency. In the next phase, database checker compares export sentences of input AS and export sentences of the peering AS. Third, database checker does the same process as import sentences. This is a class object diagram of database checker. In main method, database checker creates autonomous object from input policy. Then database checker creates some autonomous objects as peer ASs based on specification of input autonomous object. In import check and export check method, database checker compares specification of root import and root export between these peering AS according to foregoing explanation. Policy checker gives the operator an opportunity to examine the policy which he intends to register to IRR database. The process is like this. The policy input by an operator of transmitted to policy checker, which is deployed as a Java servlet on Apache and Tomcat. Policy checker creates an AS object from input policy and transmit it to database checker. Then database checker examines consistency between input policy and peer AS's policy. Database checker returns the collected information of inconsistency to policy checker. Policy checker generates HTML document from the result of examination and displays it to the operator's web browser. The process of examination is given with web-based interface. If any inconsistencies are detected, policy checker notifies the warnings on the operator's web browser. Then the operator of the AS may correct the corresponding entries and register the consistent policy. This is an example of query to policy checker to examine policy. Users will write in their policy in this text area and click submit. Within 1 minute, policy checker returns results like this. If policy checker detects any inconsistencies, it signifies them in red lines like them. If policy checker in this example, it takes about 30 seconds for examination. The time for examination depends on the number of import and export sentences. By correcting inconsistencies between peering ASs, it is possible to exchange root information between ASs that are not directly peering. Eventually, it is also possible to prove the consistency of the whole IRR databases. For example, in this situation, the requirement is to give S1 connectivity to S2 and S3. To satisfy this requirement, each AS has to declare to import or export expected routes. At initial state, S2 doesn't export route of S3 to S1. Furthermore, S3 doesn't export the route of S3 itself to S2. At this state, route of S3 is never transmitted to S1, so that S1 can't establish the connectivity to S3. At this state, if the operators use policy checker, it tests them that S2 doesn't export the expected route of S3, so that the operator of S2 would be able to correct the corresponding entry. However, at next state, policy check tests the operator of S3. S3 doesn't export any routes to S2. Based on this warning, the operator of S3 would be able to add entry properly. As a result, the policies of each S are corrected and S1 would be able to get the root of S3. Finally, connectivity between S1 and S3 is established. Thus, by using policy checker, it is possible to check consistency between S's that are not directly pairing. As a result of the examination, we have found that 55.8% of S has at least one inconsistency on IRR databases. This figure tells us that there is a deviation in the number of inconsistencies by the S number. In other words, inconsistency increases as the number of S becomes larger. We are sure that the S with a small s number tends to have many pairs so that the S has many import or export sentences and many inconsistencies. We divided this result into two groups which have large S number and small s number. The analysis of the inconsistency of each group is shown in this figure. This figure shows that the group with small s number has higher rates of inconsistency of pairing S doesn't exist on IRR database. The red one. In other words, S especially with small s number are required to check whether the pair exists in the database. Irrespective of S number, operators to update their policies frequently. Excuse me. The detail of the inconsistency in all of import and export sentences are shown in this table. In this table, the red column shows the rate of each inconsistencies in roughly 200,000 import and export sentences. In this table, inconsistency number 3 and number 4 occupy 36% of all import and export sentences. In other words, although pair S exists in IR database, most of them don't specify the S as a pair. RPSL is designed to describe the routing configuration, particularly by import and export sentences. Operators can decrease the overhead of operating their BGP routers. However, we found out that this functionality is scarcely working. Now I'm a member of JPNIC IR planning team, which is operating IR server maintained by JPNIC. In near future, we intend to apply policy check server to JPIRR that is an IR server and provide a service to examine the consistency. A mechanism for preventing increase of inconsistency of IR database record has been presented. We define this inconsistency as categories: inconsistency in routing, information import and export. Based on this classification, we propose policy check server. Policy checker gives the operator an opportunity to examine the policy that he intends to register to IRR database. Database checker is a system to investigate consistency of AS policies in the whole IRR databases in the world. As a result of the examination by database checker, we have found out that 55% 8% of ASs has at least one inconsistency. We advocate that the operator of AS should take the consistency between other ASs policies into consideration before he registers his ASs policy to IRR. Thank you for your attention.
Okay, thank you very much for the presentation. Do we have any questions from the floor? Or are you all completely confused and baffled?
On slide 20, there were different inconsistencies, but one S can have a few consistencies, and which what was classification? The first inconsistency detected on this AS, or the most important? If one S has a few inconsistencies,
Yes.
to which category will?
Yes. Is most important. I think two categories, number 3 and number 4, is
are the most important.
they're most important, because if S has inconsistencies, maybe the connectivity between S is lost.
Okay, thank you.
Do we have any more questions from the floor? I have one question.
Yes.
Where is this implemented? Is it implemented centrally, or is it implemented in each AS?
I think it will be implemented at not AS, but IX, Internet Exchange, or Internet Routing Registry, on Internet Routing Registry.
Okay, so what plans do you have to roll this out? You're going to pilot it in, what was the acronym? In the JPNIC.
JPNIC, yeah.
Do you have plans to roll it out further than that later?
Yes, I'm going to implement my system on JPIRR.
Okay. Well, can we thank our speaker? Thank you very much.